Hi there, David Topman, Esri Water Guy. I'm standing here at the banks of the Thames River, and behind me you can see the Thames Barrier. It's probably one of the most significant flood control projects in all of England. More about that later, but the Thames River at 236 miles. It is the longest river in England, the second longest river in all of UK, and you can see by the river's color it gets its name from the Latin word tamesis, meaning dark. So the dark river, basically it gets that from the sediment. It was first recorded in early Roman times in 50 BC. That's 50 BC, where the Romans kind of settled early London between two hills, kind of where the London Bridge sits right now. And the Thames River has always been a tidal river, and actually at the London Bridge is the official tidal recording station. The river fluctuates as much as 23 feet between low tide and high tide. It's quite a sight to see that, you know, at low tide the docks are all angled down in the mud and boats are sitting on the banks, and then high tide, you know, the docks raise back up and the boats are navigating up and down the river. It's that tidal influence that causes quite a challenge for water resources, for flood management. Actually back in 1810 they built the Teddington docks, which is roughly 55 miles that way, southwest of London. And the Teddington locks was helped control the floodwaters from reaching inland. It was built, say, in 1810 and rebuilt in 1867, but really splits the river into two pieces, the tidal and the non-tidal. And the non-tidal reaches way up there past Oxford University, where historically it's been called the Isis River, but really is the Thames the entire way. So again, there's the tidal portion, which they call the tideway, that goes from the Teddington locks all the way out here past the barrier to the North Sea, to the Thames estuary. But it's this the tidal challenge that has caused flooding, and the Thames Barrier was built to handle floodwaters coming in from storm surges from the North Sea. It was actually conceived of back in 1969, and they began construction and became operational in 1982. And so what you're seeing there are these large gates. The four gates in the middle are allow ships to go through, and then there's more gates here on the side that just allow flood control. But those gates in the middle are 66 feet tall, made out of 1.5-inch thick steel. They lay flat during navigation, and then they can raise them up. They're these half cylinders that they can raise up to close the river. They each weigh about 3,700 tons, so it's been a engineering marvel. It's quite expensive, about $1.5 billion to build, but it has been very effective in flood control, preventing storm surges from the North Sea. It's been operated 176 times since it was built. Literally, it was operated 50 times about 2 years ago in the water year 2013 to 2014, yet the water year 2014 to 2015 was operated only once. So anyway, it's very effective for flood control, an amazing structure. Privileged to bring this to you. Again, this is David Topman, Esri Water Guy. If you have any questions, email me, dtopman@esri.com. Follow us on our meetups at meetup.com/Esri-Water-Meetup. And hopefully I'll see you folks maybe in a couple weeks in Chicago at the AWW ACE, if not the week after in San Diego at EdderUC. So again, David Topman, Esri Water Guy. It's been a privilege bringing you these videos, and I know I'm just amazed at all the different water structures across the planet, and the Thames Barrier is definitely one of those engineering marvels of the world. So thanks for sharing with me. We'll talk to you later. Bye.